and welcome to Aerotech's Automation1 Motion Control Platform Educational Series. Aerotech is a company that solves your toughest precision motion and automation challenges. Automation1 is a motion control platform consisting of software-based controls and development tools, PC and drive-based control hardware, and hardware-based drives for servo motors and other devices. In this video, you'll discover the features of Automation1's file system and how they function. My name is Alex, and I'm a control systems specialist for Aerotech. What is the file system? The Automation1 controller supports a hierarchical file system with directories and files. This is where the machine's AeroScript programs, libraries, data collection files, and other user files can be stored. Effectively, this operates like your typical Windows computer file system with the ability to store your files within user-created directories and file paths. This ability to store programs and other data on the controller ensures that the controller's behavior remains consistent regardless of the configuration of the connected MDK machine. So how can we access the user file system? Well, there are a few different ways we can access the controller file system. The first is through the Configure Workspace interface. This is the most simplest. To do this, you have to go up through the Configure Workspace interface and then down to the Controller Files tab. From here, you can see how the file system resembles your usual file system-like interface like you might see in Windows. Access to the Configure Workspace allows you to navigate through and sort the files, directories, create directories, copy files, delete your files, and open the source and plot files, all from this interface. You are also able to upload files from your local system, i.e. the computer, to the controller, as well as download controller files to your local system, i.e. the computer. In our first example here, we're going to be using an IXC2E drive-based controller, and we're going to be creating a folder and doing some quick basic testing just to show you the functionality that we can access through this interface. So first, let's go ahead and create a file. We're going to start by creating an initial test folder here and just call it test. And we can double click to open that. And let's actually go ahead and then upload a file to this folder. Now, before we do that, quickly jump over to the desktop and create a text document. We can open that and verify that there are no contents inside. So then let's go ahead and upload files. Select our desktop, search for text files, and it has it uploaded there. Now we can right-click this and select Open to actually view and modify the text file directly here from the Develop workspace. So let's go ahead and do that. And then jump back over and we'll download this from the controller onto our computer. So we can do that using either the right-click or the navigational buttons at the top. Now, to make a distinction, we'll name this something else so that we can go in and verify that the plot contents that we just made do show up here. So now if we jump back over to the desktop, we should see our new file, and if we open that, we can verify that it matches what we just wrote to our file. Now, if you were to go back and open up that original text file that we created on the desktop, you'll notice that it would still be blank because, well, we didn't edit that file. We edited the file that we uploaded to our controller. And that, of course, is an important distinction we have to make. So our uploading, downloading, and editing of the files should be as simple as doing something like this. Now, the second and third methods for interacting with the controller file system involve using either AeroScript commands or our APIs. Both the AeroScript and API commands allow you for another easy way to interact with the file system, mainly just including the ability to read and write to the file contents. In this example, we will be using AeroScript commands to open a file or write to the file, then read from that file and display a message on the Automation1 banner. The specific example we are running can be found in the help file, however, you can also pause the video and just copy it straight from here. So here are going to be our initial commands to create the file and open the file that we want to edit. Now we can see here, this is our file path to the my text file. But if we were to look at that in our file system, we'll notice that it doesn't actually exist. There is no my files, then my text file.txt file path. Right now, we just have Automation1, example programs, and test. But running this program should create a brand new file called my text file with a folder called my files. Here we can see the actual contents that we're planning on writing to the file. We then close it, and then we reopen it in read mode, and then finally write those contents to the Automation1 banner. So it should show up either up here at the top or on our notification bar. So let's go ahead and run. And we can see that it shows up on our notification bar and the top banner. And if we jumped over to the file system itself, we'll see that we now do have a new folder called My Files with a new file called My Text File. We can open that file up and of course verify that the contents that we thought we were writing do actually show up here. So why is this important? Well, functionality like this is quite useful in both data collection and storage. The ability for a user to create their own files and log files, recordings can be invaluable as a feature. By utilizing something like text files and these file system commands, we would be able to record and store stage information like position, velocity, or current commands, and then store them on a separate file within the controller file system. Now, briefly switching gears for a second, there are a few very important details that you should know about the controller file system, as well as some more minor details. First and foremost, you cannot write or specify Windows directories from within the AeroScript programming language. Automation1's AeroScript language only reads and writes to the Automation1 controller file system. It will not read or write to a Windows directory and file path. To achieve similar functionality where you can write from AeroScript to a file stored at a Windows directory, you're going to have to use some form of the Aerotech APIs, either through simply using the APIs to gather and write the information directly, or use some form of a custom DLL or executable written using the APIs that can then achieve the needed collect information and write data to the file on the Windows side of things. You could then call this custom DLL or executable using something like the callback command. Another, albeit a small detail, is that unlike a Windows PC file system, the Automation1 controller file system utilizes the / character instead of a backslash in the programming commands. So if you are trying to manipulate the controller file system via AeroScript or the API commands, just keep that in mind. Like a Windows file system, however, all paths are absolute paths within the controller file system, meaning there is no assumption about where the file is being stored if you don't give it an absolute file path. So if you do want to reference any file within the controller file system, you must provide the full file path on the controller. Additionally, controller file paths are not case sensitive. So a file with capital letters can be opened and written to using non-capital letters from within programming commands. Finally, what about limitations? If this is a file system, aren't there memory constraints on the controller? And yes, you would be correct. Because this is a file system, there are memory limitations on what each controller can actually handle, especially for drive-based controllers where the memory is self-contained on the drive itself. For PC-based controllers, this file system limitation is limited only by whatever the computer's memory storage limitation is. This is because the controller file system lives on the computer where the ISMC is. On the other hand, for drive-based controllers, the storage limitation is roughly 5 gigabytes. This is just due to the nature of standalone drives and the memory capabilities currently available. Again, this is because the ISMC controller lives on the drive itself, and so all the memory is stored there as well. Now, this is just the memory available offline for a drive-based controller. While connected to a computer, they are still able to access files located on the computer itself. So if you stored your AeroScript programs or MCD files on the desktop, you can still open and run those from the desktop. Just the onboard user file system has this roughly 5 gigabyte storage limitation. That said, though, this does not mean that you can simply open and run whatever size file program that you want on a PC or drive-based controller. You could certainly try to upload large gigabyte-sized files to the file system, but the Automation1 controller is not going to be able to run programs more than a few 100,000 lines long. So because of this, our compiled programs should only have a maximum size of about 200 megabytes. On these rare occasions, though, where you do have very large programs that you need to run, Automation1 does have a feature called the command queue that can be used for these much larger files. This feature does, however, require the use of our C or .NET APIs to operate. Finally, if you do want to know the available memory that you have left to use on the controller, you can find this using the file info command through the Automation1 console. Specifically, we want to look at the available user space line. In this image, we can see a value of 5.2 G. This indicates that we have 5.2 gigabytes of available memory on our iX2E drive-based controller. This is what we're running in our example. This, in essence, summarizes what the file system is, how we can access it, and how we can use it. That concludes this motion control platform educational video. Thank you for watching, and I hope you enjoyed learning about the Automation1 controller's file system and how it functions.